Hello my dear students. Today we will talk about the electric lamps, and this lesson is for grade 6, unit 2, lesson 1. It's known that the sun is the main source of light, but in the old centuries man felt that daylight is not enough, so he started to search for artificial light sources such as fire torches, candles and oil lamps. After the discovery of electricity, man uses the electric lamps instead of fire torches, candles and oil lamps. The electric lamps represent a constant source of light that's clear, bright, and free from smoke, vapor, and odor. In this lesson, we will study two main subjects. The first one is the electric lamps, and the second one is the electric circuits. Let's talk first about the electric lamps. The electric lamps produce light when the electric current passes through them. But what is the meaning of electric lamps? The electric lamps are tools that convert electric energy into light energy. And what is the meaning of electric current? The electric current is the flow of electric charges, electrons, through a material conducting electricity. There are different types of electric lamps. The most popular of these lamps are number 1, the light bulbs, number 2, fluorescent lamps. First, let's talk about the light bulb. Thomas Alva Edison is an American inventor who invented the light bulb. What are the uses of the light bulb? The light bulbs are the most popular source of artificial light, and they are used in lighting houses, car lights, and torches. What is the structure of the light bulb? We find out that the light bulb consists of three main parts, which are the filament, the glass bulb, and the base of the light bulb. Again, the filament, the glass bulb, and the base of the light bulb. Let's talk first about the filament. The filament is a coiled thin wire made of tungsten. Again, a coiled thin wire made of tungsten. Electricity reaches the tungsten filament through two wires made of copper and lead. And these two wires are connected to the base of the light bulb. Again, the electricity reaches the tungsten filament through two wires. One of them is made of copper and the other one is made of lead. And these two wires are connected to the base of the lamp. The function of the filament is to heat up and emit light when the electric current passes through it. The function of the filament is to heat up and emit light when the electric current passes through it. The function of copper and lead wires is to connect electric current from the base of the light bulb to the tungsten filament. So they allow the electric current to transfer from the base of the lamp to the tungsten filament. The filament of the light bulb is made of tungsten because this metal has high melting point. What is the importance of having high melting point? It means that it prevents the melting of the filament at high temperatures. When the filament heats up, it will not melt easily because it has high melting point. So the filament of the light bulb is made of tungsten. Why? Because it has high melting point, and the high melting point prevents the melting of the filament at high temperatures. The second part of the light bulb is the glass bulb, and the glass bulb is made of thin glass. The glass bulb contains one type of inert gases as the argon gas instead of air. The glass bulb contains inert gas. What is the meaning of inert gas? The gases are classified into two types, active gases and inactive gases. Inert gases mean inactive gases, and inactive gases mean that it doesn't react with any material. So the glass bulb contains one type of inert gases, which is the argon gas instead of air. The function of the glass bulb is to prevent air from reaching the filament to protect it from burning. prevents air from reaching the filament to protect it from burning. And what is the function of the argon gas? It protects the filament from burning and increases the lifetime of the filament. Again, protects the filament from burning and increases the lifetime of the filament. So we have here the second part of the light bulb is the glass bulb. It's made of thin glass. The glass bulb contains one type of inert gases, which is the argon gas instead of air. The function of the glass bulb is to prevent air from reaching the filament to protect it from burning. The function of the argon gas is to protect the filament from burning and increases the lifetime of the filament. The third part of the light bulb is the base of the light bulb. And we have here two types of bases. I have here the spiral base and the two-side nails base. First one is the spiral base. It has only one piece of lead to connect the lamp to the electric circuit. The spiral base has a piece of lead, only one piece of lead, to connect the lamp to the electric circuit. What about the two-side nails base? It has two pieces of lead to connect the lamp to the electric circuit. So I have here two types of bases. The first one is the spiral base and it has a piece of lead, the two-side nails base and it has two pieces of lead, and both connect the lamp to the electric circuit. What are the functions of the base of the light bulb? First one is to carry the lamp in an upright position, and the second one, it connects the lamp to the electric circuit. So the functions of the base of the light bulb are to carry the lamp in an upright position and to connect the lamp to the electric circuit. So we have here the light bulb consists of three parts: the filament, the glass bulb, and the base of the light bulb. Now let's talk about the second type of the electric lamps, which is the fluorescent lamp. The fluorescent lamps are used for many purposes, such as lighting houses and offices, decorating commercial stores, and for commercial advertisements. Again, they are used for lighting houses and offices, decorating commercial stores, and in commercial advertisements. What is the structure of the fluorescent lamp? The fluorescent lamp consists of three main parts also, which are: the first one is the glass tube, the second one, two filaments of tungsten, and the third one is the points of connection. So I have here three parts also, but different parts. The first one is a glass tube, the second one, two filaments of tungsten, the third one, points of connection. Let's talk about the glass tube. The glass tube is a vacuumed glass tube that contains inert argon gas. Again, it's a vacuumed glass tube that contains inert argon gas and a little bit of mercury vapor. So the glass tube, a vacuumed glass tube that contains inert argon gas and a little of mercury vapor. And the inner surface of the glass tube is covered with a phosphoric material. The inner surface of the glass tube is covered with phosphoric material. The second part is two filaments of tungsten. They are found at the two tips of the lamp from inside, where each tip contains a filament of tungsten. So I have two filaments of tungsten. Part number 3 is the points of connection, and we have here 2 points of connection on each tip of the lamp. Again, points of connection, and there are 2 types of connection points on each tip of the lamp. What is the function of the points of connection? Is to connect the fluorescent lamp to the electricity. Again, the points of connection have a very important function, which are connect the fluorescent lamp to the electricity. So we have here the fluorescent lamp consists of 3 main parts, which are the glass tube, 2 filaments of tungsten, and points of connection. and we talked about each of them. Just to know, the fluorescent lamp is known as neon lamp, but the inert neon gas is not used inside its glass tube. So it has a common name, which is neon lamp, but it doesn't contain neon gas. The fluorescent lamp is existed in many shapes. That's all for the types of electric lamps. We have here two types of electric lamps, which are light bulbs and fluorescent lamps. Let's talk about the second part of our lesson, which is the electric circuits. What is the meaning of electric circuit? In grade 4, you knew that the electric circuit consists of battery, electric wires, switch, and lamp. But what is the meaning of electric circuit? The electric circuit is a closed and continuous path through which the electric current will pass, making a complete cycle. That's why we call it circuit. A closed and continuous path through which the electric current passes, making a complete cycle. The simple electric circuit consists of three main parts: battery, lamp, and electric wires. What is the importance of battery? It works as a source of electric current in the electric circuit. What is the importance of the lamp? It's used to indicate the passage of the electric current. What is the importance of the electric wires? They are used to connect the battery to the lamp in the electric circuit. So each part of the electric circuit has its own function. How to connect many electric lamps in electric circuits? We have two methods of connection of electric lamps in electric circuit. We have here two methods by which we can connect many electric lamps in electric circuit. The first one is called series connection, and the second one is called parallel connection. So we have two methods of connection of the electric lamps. The first one is series connection and the second one is parallel connection. What is the meaning of series connection and what is the meaning of parallel connection? That's what we will know now. First one, let's talk about connecting electric lamps in series connection. We have here an activity to have one way only for electricity. I have here the wire starts from the positive and ends in the negative, and we have one electric lamp. First, let's make a complete simple electric circuit. I have here battery, wires, and electric lamp. My observation that the light intensity of the bulb is strong. Why? Because I have here a battery and a lamp. So I have here only one thing that uses the electric current that passes through the wire. Let's increase the number of the lamps. By increasing the number of the lamps, we find out that the light intensity of the two light bulbs decreases. Let's increase them more. By increase them more, we find out that the light intensity of the four bulbs become very weak. What will happen when we unscrew one lamp in the electric circuit while it's connected? It means that you cut off the electric current from the circuit. So we observe that the four light bulbs are turned off. What's my conclusion from this activity? It means the conclusion is when we connect more than one bulb with the electric circuit in series connection, the lighting of the bulb decreases by increasing number of connected lights. What is the explanation for these different observations? Number one, in connecting the light bulbs in series, the light bulbs are connected one after another. Number two, in the series connection, there is one route for the electric current to pass through in the electric circuit. The electric current moves in one route, in one way only. So, by cutting this route, the electric current can't pass through it. So that's why by unscrewing one bulb, the others will turn off, because there is one route only for the electric current to pass through it in the electric circuit. Explanation number three, that when we cut a part of this root by unscrewing one bulb, or when the bulb burns out, the current doesn't flow in the circuit, so all the light bulbs are turned off. Again, when we cut a part of this root by unscrewing one bulb, or when the bulb burns out, the current doesn't flow in the circuit, so all the light bulbs are turned off. So here, from this explanation, we can conclude that the series connection cannot be used in houses, because when we unscrew one bulb, or even if one bulb burns out, the current doesn't flow in the circuit, so all the light bulbs will turn off. So here, that's all for the series connection. In the series connection, we connect the light bulbs one after another. And in the series connection, there is one route for the electric current to pass through in the electric circuit, and by cutting this route, by unscrewing one bulb, or when the bulb burns out, the current doesn't flow in the circuit, so all the light bulbs are turned off. What about the parallel connection? In the parallel connection, we will connect the same number of light bulbs, but in a different way. We will branch the root of the electric current. How? By this drawing. Here, I will connect two lamps, but in this way, by branching the root of the electric current. We find out that the light intensity of the two bulbs is strong. By increasing the number of the lamps until they become 4 lights, we find out that the light intensity of the 4 bulbs is the same and doesn't decrease. The light intensity doesn't decrease by increasing the number of electric lamps. If we unscrew one of the lamps while they are connected, the others will not turn off. The other remain lighting as they are. So the observation here that the unscrewed lamp is turned off, while the other 3 lamps are lighted up with the same light intensity. So in the parallel connection, by increasing the number of the lamps, the light intensity doesn't change. And by unscrewing one lamp, the other lamps will not turn off. The conclusion: when we connect more than one bulb with the circuit in parallel, the lighting of the bulbs remains as it. Their intensity doesn't change. The explanation is, in connecting light bulbs in parallel, the light bulbs are connecting in branching routes. In parallel connection, there are more than one route for the electric current to pass through in the electric circuit. And when we cut one of these routes by unscrewing one of the lamps, the electric current moves in other routes, so the other lamps in the circuit do not turn off. Why? Because I have more than one route. So nothing changes when one route is cut off by unscrewing the lamp or by burning it. So here, when we cut one of these routes by unscrewing one of the lamps, the electric current moves in other routes, so the other lamps in the circuit do not turn off. So here, in connecting electric lamps in houses, we prefer parallel connection. Why? Because if we unscrew one lamp, or if one lamp is burned out, the others will not be affected. And by increasing the number of the lamps in the houses, and by increasing the number of the lamps in the house, the light intensity doesn't change. Give reason: in the decorative lights used in religious celebrations and weddings, if one or more lamps burned out, the other lamps do not turn off. Why? Because the lamps in decorative lights are connected in parallel connection. Why? Because the light bulbs are connecting in branching routes, because the electric current passes through more than one route. So the electric current flow even if there is unscrewed one lamp or a burned one lamp. So in parallel connection, there are more than one route for the electric current to pass through in the electric circuit. That's all for this lesson. I hope you enjoyed. Stay home, stay safe, and good luck.